Dear viewers, welcome to Chemistry with Fun. Today's topic is same radioactivity lesson 4. In lesson 3, we have studied the different characteristics of alpha, beta and gamma ray, and when alpha, beta and gamma ray ejects from a radioactive nucleus, what change occur in the radioactive nucleus. Today we will study the group displacement law of Fajan and Soddy. Okay. Fajan Soddy group displacement law. We know that when an alpha particle ejects from a radioactive nucleus, the mass number is decreased by 2, and the mass number decreased by 4, and atomic number is decreased by 2 in the daughter nucleus. And when a beta particle ejects from a radioactive nucleus, there is no change in mass number, but atomic number is increased by 1 in the daughter nucleus. From this point of view, Fajan and Soddy, two famous scientists, proposed a theory relating to the position of the radioactive nucleus in the periodic table in the year of 1913. They proposed that when an alpha particle ejects from a radioactive nucleus, the daughter nucleus will be placed two group left side in the same period in Mendeleev periodic table. We know that when an alpha particle emits from a radioactive nucleus, will be change in the atomic number. Atomic number is decreased by 2 in the daughter nucleus. As atomic number is decreased by 2, the daughter nucleus will place two groups left in the same period in the Mendeleev periodic table. And second proposed theory was when a beta particle ejects from a radioactive nucleus, the new daughter nucleus will be placed one group right in the same period of Mendeleev periodic table. Means we know that when a beta particle emits from a radioactive nucleus, the atomic number increased by 1 in the daughter nucleus. As the atomic number increased by 1, the daughter nucleus will be placed one group right side in the same period of Mendeleev periodic table. Let's take an example of these two theories. Let's take bismuth. Its atomic number 83. A beta particle is released from it. Sorry, atomic number written in the bottom side. A beta particle released from bismuth. As beta particle released, the new daughter nucleus atomic number will increase by 1. Let the daughter nucleus is Y. Its atomic number will be 84, and the daughter nucleus is here polonium. If alpha particle is released from bismuth, then atomic number will be decreased by 2, means it will be 81. Here X is thallium. Bismuth is a radioactive nucleus whose atomic number is 83, from which a beta particle is emits. As the beta particle is emits, atomic number is increased by 1 and it is placed one group right side. Bismuth is placed in period 6. Group 5A. Polonium is placed in same period 6. Group, one group right side. When an beta particle ejects from a radioactive nucleus, then polonium will be placed in group 6A. In the similar way, bismuth is a radioactive nucleus. When an alpha particle is emits from it, its atomic number is decreased by 2 and it's placed 2 groups left in the same period of the periodic table. Bismuth is placed period 6, group 5A, then X means thallium. Thallium will be placed in period 6 according to Fajan Soddy rule. displacement law, its group will be, it's 5a, it will be 3a. Okay? This theory was proposed by scientist Fajan Soddy in the year of 1930. Now I am going to discuss about disintegration series. Disintegration series. What is disintegration series? Now, in the definition of radioactivity, we have studied that any unstable nucleus undergoes stabilization in a spontaneous process. The process continues till then until the radioactive nucleus gets stabilization. Okay? In the same way, when a radioactive nucleus undergoes stabilization, a various daughter nucleus is formed by emitting alpha, beta, gamma rays. The whole process, all parent and daughter nucleus connecting together form a chain-like structure. This chain-like structure is called disintegration series. The definition would be when a radioactive nucleus undergoes successive disintegration for getting stability, the process will continue until a stable non-radioactive nucleus is formed. In this way, several daughter nucleus is formed by emitting alpha, beta rays. This whole process form a chain-like structure. This is called disintegration series. Means a radioactive nucleus when tends to get stability, undergoes disintegration. This process continues until a stable non-radioactive nucleus is formed. In this way, several daughter nucleus is formed by emitting alpha beta ray, and this whole process formed like a chain like structure. This is called disintegration series. There are several disintegration series like uranium series, thorium series. Point 1, uranium series. It is also denoted by 4n plus 2 series, where n is an integer. Okay. Uranium series also denoted by 4n plus 2 series. The starting radioactive nucleus of uranium series is U92-238. Atomic number 92, mass number 238. And it goes to stable product by various stages by emission of alpha and beta ray. And the last stable product is lead, 82-206, where 82 is the atomic number, 206 is the mass number. But this process occurs in 14 steps by emitting 8 alpha and 6 beta. This is called 4n plus 2 series because when we divide the mass number of each nucleus is formed mass number is, when we divide the mass number by 4 of each nucleus is formed in this series. That will give remainder 2 in each and every step, because 238 its mass number when divided by 4 20 give remainder 2. If 206 is divided by 4, then give remainder 2. Each and every step this series give remainder 2 when the mass number is divided by 4. In this, so this series is called 4n plus 2 series. The starting element of this series is uranium 92-238 and the stable element which get product is lead 82-206. It occurs 14 steps by emitting 8 alpha and 6 beta. Okay. Next we come thorium series. TH for thorium. It is denoted by 4n. Its starting radioactive element is thorium. Atomic number 90, mass number 232. Stable at the end of the series, stable product is lead. Atomic number 82, mass number 208. This series is called 4n because when the mass number is divided by 4 in each series gives no remainder. When the mass number of each nucleus is divided by 4 in this series gives no remainder. 232. So this is called 4n by 4. 32. It is 208. Gives no remainder. So it is called 4n series. And this, from this nucleus to this nucleus takes n steps by emitting 6 alpha and 4 beta. There is another radioactive series which is called actinium series, denoted by 4n plus 3. Its starting element is uranium 92, and last stable product is lead 82, 207. This series consists of 11 steps, 7 alpha, 4 beta. This is called 4n plus 3 series because when the mass number is divided in each step by 4 gives remainder 3 in each step. 235, 4. Gives remainder 3. If we test 207, gives remainder 3. So it is 4n plus 3 series. And there is another artificial radioactive series. Artificial radioactive series, that is Neptunium series. That is 4n plus 1 series. The starting nucleus is Neptunium 93, 237, and end product is bismuth 83, 209. It is called 4n plus 1 because if the mass number is divided in each step by 4 gives remainder 1. Okay, these are the 4 radioactive series. Uranium series, thorium series, actinium series, and Neptunium series, which is artificial. These are the 4 radioactive series. consists, in uranium series we have studied that U92 238 gives product lead 82 206. This is uranium series. Gives from this stage to this takes 14 steps, 8 alpha and 6 beta ejects from the nucleus. But how can we confirm that from this to this ejects 8 alpha 6 beta? There is a mathematical formula. Number of alpha particle ejects in a series. The mathematical formula is mass number of starting radioactive nucleus in the series minus mass number of the last stable nucleus. The whole is divided by mass number of an alpha, that is 4, because we know that alpha particle is denoted by 2He4. The mass number of alpha particle is 4. And number of beta particle ejects in the series. Number of beta particle. The formula will be atomic number of the last element in the series plus number of alpha particle into 2, the whole is subtracted from atomic number of first radioactive element in the series. Okay. formula of beta particle is number of beta particle formula is atomic number of last element in the series plus number of alpha particle into 2 minus atomic number of first element in the series. Okay, let's take an example to prove that in uranium series 92 to 38 to lead 82 206, it consists of 14 steps, 8 alpha and 6 beta. Number of alpha particle according to formula, number of alpha particle is mass number of starting radioactive nucleus in the series. The mass number of starting radioactive nucleus is uranium, so mass number is 238 minus mass number of last stable nucleus in the series. Last stable nucleus is lead, whose mass number is 206. The whole is divided by mass number of an alpha particle, that is 4. Divided by 4 equal to 8 alpha. Here 8 alpha is 2. Now we can calculate the number of beta particle according to the formula. Number of beta particle formula, atomic number of last element in the series. Last element is lead, atomic number is 82, plus number of alpha particle. Number of alpha particle, here we calculate that number of alpha particle is 8 into 2, 8 into 2 minus atomic number of first element in the series. Atomic number first in the series is 92, which is uranium, minus 92. 82 plus 16 minus 92 means 98 minus 92 equal to 6. Here 6, and we conclude that 6 beta particle. From this mathematical formula, we prove thorium series, actinium series. Okay, this is all about disintegration series. Now we calculate a series by emitting alpha beta. What change occurs now is, let's take an example. X 92 to 38 alpha particle, Y again alpha, Z beta, D alpha, E beta, F, 2 alpha, G, gamma, H, beta, I. You have not to recall the name of the nucleus. You can denote it X, Y, J, D, B, etc. But you have to balance by calculating alpha beta particle, the atomic number and the mass number. From X, an alpha particle is released. We know that when an alpha particle is released from a radioactive nucleus, the atomic number is decreased by 2 and mass number is decreased by 4 in the daughter nucleus. Then Y should be (90 to 34). Again alpha. Then Z should be 88 to 30. Beta. When a beta particle ejects from a radioactive nucleus, we know that there is no change in the mass number, but atomic number is increased by 1, and the new element is placed one group right side. Then D, a beta particle is released from Z, then it will be D will be 89 to 30. Again alpha, E will be 87 to 26. Again beta, F will be 88. Mass number would not be changed because beta particle is released. 226. 2 alpha. In G, 2 alpha is released. 2 alpha means for 1 alpha particle mass number is decreased by 4 and atomic number is decreased by 2. For 2 alpha particle mass number should be decreased 4 into 2, 8, and atomic number should be decreased 2 into 2, 4. Then G would be 84 and F will be 218. Gamma. We know that gamma particle is released in the when alpha after emission of alpha beta particle, the excessive energy is released, but there is no change in the nucleus. So it would be same 84 218 because the nucleus will be remain same. It will be not H, it will be same G. The nucleus is not changed. H will be G. Again beta. Then I will be atomic number will increase by 1. Mass number will remain same 218. Okay. Because in case of emission of gamma, there is no change occurring in atomic number and mass number. The nucleus remains same. So here the nucleus will be G. No new nucleus will be formed. Now I am going to discuss the units of radioactivity. Units of radioactivity. The unit of radioactivity is disintegration per second. In short form, it is denoted by dps. But its value is so high, so it is replaced in terms of Curie. So what is Curie? When the activity of a radioactive substance is 3.7 into 10 to the power 10 dps, means disintegration per second. It is called Curie. Curie is also denoted in its fragments millicurie and microcurie. 1 millicurie equal to 10 to the power minus 3 curie, and 1 microcurie equal to 10 to the power minus 6 . It means 3.7 into 10 to the power 7 dps. It comes 3.7 into 10 to the power 4 dps. Okay. Another unit of radioactivity is Rutherford. Rutherford. When the activity of a radioactive substance is 10 to the power 6 dps, it is called 1 Rutherford, denoted by R, capital R, small d. And the SI unit of radioactivity is becquerel, becquerel, denoted by BQ. When the disintegration is 1 per second, is called becquerel. Becquerel is, this is the SI unit of radioactivity. Three type of units has arisen: Curie, becquerel and Rutherford. Becquerel is the SI unit. Okay. Name of the instruments which is used for measurement of radioactivity. One is Geiger Muller counter, and second is Wilson cloud chamber. These are the instruments which are used for measurement of radioactivity of a radioactive element. Okay.